talk over me. Okay, so the ladies can be a little quiet. There we go. So here's what. The whole point of math, maybe this is why I became an economics major. I started as an engineer at Cal, and I remember studying for a test in the engineering library, and some horrible, terrible dork of a guy was literally clipping his toenails in the library, and I thought, I do not want to major in this, because the people who major in this are disgusting. So the reason I'm an econ major is because of this. If you take social studies and you take math and you put them together and they have a baby, that's really what economics is. So I like teaching math, but I really like teaching it when we can use it for real stuff, right? Like, I didn't hate those problems where we found how big the dog pens were. Thought that was cool, that you could actually figure that out if you knew how much fencing you had to make the most amount of space for your dog. I like that. So what we're going to be doing today is this. For the next 4 days, we're going to be talking about the fact in real life, this is sad, you are either doing one of two things. Everything in the universe is either growing or it's decaying. You are all still growing in some way. Sadly, I'm not, right? And in real life, things are either getting bigger or they're getting smaller. They don't just stay the same. And it happens in stuff that we do that's not real, because money is not really real, but we make it work. It happens when we talk about things depreciating. It also happens in nature when we have viruses grow or zombies attack, right? So all of this stuff happens, and it doesn't go slowly. It doesn't go linearly. It kind of shoots up because it grows on itself. So we're going to talk about, for the next 4 days, exponential growth and decay. And we're going to start really easy with some basic stuff, basic exponential growth and decay. And then we're going to get to natural growth and decay. We're going to get to half-life. Your Nana's going to find a bone in her backyard. We're going to try to see how old the dinosaur bone is. And we got stuff like that. Are you ready? So, let's see, I don't want to say this. I think I might put you guys just right here for a second. Is that okay? No, just a four. Like, you could go together, right? Like, just back up. Just because I just hear it out of the corner of my ear. Here I won't notice it. Okay, you just random. That was me. Are you ready? We're going to write this down. Are you guys ready? Good to go. So we're going to start right here. We're going to say that all exponential stuff, whether it's getting bigger or smaller, looks something like this. You're going to write that down. A to the bx. The reason that these everything we're going to do is exponential is because here's like something genius. It's going to all have an exponent in it somewhere. Every day I'm going to give you a slightly different formula. I'm not even going to make you memorize those formulas. Again, my goal is that you know how to use those formulas, right? But all of them are going to have this basic setup, right? And there's a thing in all of these right here called the multiplier, right? And it is going to be the thing that's going to make our stuff either bigger or smaller. If it turns out, if B is more than one, it is growing. If it's exactly 1, it is what we call static, meaning it's not getting bigger or smaller, it's staying the same. And things might stay static for a little bit of time, but not really. And then finally, if it is between 0 and 1, right, it is decaying. It is getting smaller and smaller. It does not ever become negative, right? It just doesn't happen that way. So it is going to be either between 0 to like 9 or 0.999999 or a fraction, or it is 1, which is static, or it is more than 1. And that's called the multiplier, right? And then we will have an exponent, and we might have a number in front, right? And we know how to do all this stuff because we literally just did a problem that looked just like that, right? Like we literally did this problem. We have the multiplier, we got a number in front, we're good at it. But today, we're going to start with our easiest way to do exponential growth and decay. And it is called simple exponential growth and decay. It's usually what we use for things that are not found in nature, right? Nature's weird, and we'll talk about her tomorrow. So here comes our first formula. And you're going to want to write this down. And it's not that the formula is hard, and it's not that I won't give it to you on a test. I will. I don't care. It's how you use the formula. So here we go. Let's see if you remember this from Algebra 2. It looks like this. 1 plus R to the T. There. Oh, let me make that look better. There she is. This is exponential growth. This is things that are getting bigger. 1 plus R to the T. So let me tell you what all these letters mean, because that's the key part. Because the hard part is not the formula. You're going to find tonight. It's super easy. It's knowing what goes where. Now, the first thing we're going to start with, you think I'd start with A because it's on top, but I'm not. The first thing I'm going to start with is what is called P. And P in math terms is called principal. It means your starting amount. So what I want you to write really big right here is this is the amount you start with. Let me put amount. Amount that you start with. It's your starting amount, right? P, how much you start with. A is the amount that you end with. So it's your end amount. I'm actually going to spell that. Like my board's off a little bit for some reason. There we go. End amount, right? R is going to be the rate that things are growing, right? And they always give it to us. So I'm going to write rate here, but they are almost always going to give it to us as a percent. But we don't want a percent. And I love you, little lamb chops, so much. But so many of you, I swear to God, someone on a test, I will say 7%, and they will go like this, 0.7, because you're a sweet lamb chop, but you're kind of dumb, right? It moves it 2 times, right? So 7% does not become 0.7, it's 0.07. So make sure you remember how to change it to a decimal. Okay, and finally, what does T stand for? T stands for time, because things are happening over time. Things are happening over time. So, one of the things that's happening to us right now, we're in a thing called late stage capitalism. And there's a little bit of a problem with late stage capitalism that we didn't expect. And that's called wealth absorption. Well, wealth absorption is this. We did not expect that there would be multi-billionaires. The problem with a multi-billionaire is that they can put their money in a bank and it will start absorbing too many resources, right? Because if you put $100 in the bank and you make some interest, that's okay. If you put $100 billion in the bank, it's bad. It takes up too much of society's resources. So we're going to talk about how that happens, right? So our first example is this. You got your Nana. Your Nana loves you. And your Nana is a bingo playing lady. She loves playing bingo. And when you were 3 years old, your Nana won $1,800. Go Nana. And she came to your house and she said to your parents, I'm going to give you that $1,800, but I want you to put it in an account and I want you to sit it there till they're 18, and I want them to take a trip on it, right? So let's figure out how much money you're going to get in your sweet, sweet Nana account, right? You were 3. You didn't even know it sat there. But it's going to sit there for 15 years. You're going to do nothing, and your parents are going to say at graduation, oh, by the way, here's some Nana money. Are you ready? So here's how I do it. I am not going to lie. I write this down every time. If you ask me questions tonight, I'm going to want to see that, because if I don't see it, I have a hard time helping you, right? So here we go. Nana is going to give you $1,800. Where does that $1,800 go? A, P, R, or T? See? It's P. It's where I'm starting from. It's Nana's giving me $1,800. Go ahead and just set it down, babe. Thanks. Now the next thing is Nana's got a pretty good financial guy because right now the common interest rate's about 4%, maybe 5%, but Nana's got a good financial guy. Good for Nana. So your percentage rate that you're putting in, not 7%, 7%, right? Nana's going to want you to put in the bank for 15 years. Go, Nana, right? Let's see what you get. Let's see what you get. And the reason I put this problem on, if you're like, Ms. T, this is not hard, I need you to make sure you know how to use your calculator correctly. So we're going to say 1 plus 0.07 or 1.07, and we're going to raise it to the 15. Get your calculators out because you need to remember how you. I had a kid earlier today who literally did 1.07 times 1.07 times 1.07. Yeah, don't do that, right? Don't do that. So you have some buttons to pick from depending on your calculator. I have a button that looks like this. I'm using that. Some of you have a button on the little black calculators that looks like that. That means to the, right? So I would say 1.07 to the 15 or 1.07 and then 15. They don't have buttons. Like here's what, lambs, order of operations matter. Do not do 1,800 times 1.07. No, no, no. Exponents first, then multiply. Talk to your neighbors. Can you take a nice trip to a graduation trip on the money you're going to get from Sweet Sweet Nana's bingo winnings? Talk and decide.
Are we doing two?
We're doing this first one. Okay. Do you have a calculator?
I already got.
Oh, you already did? Okay. So I'm going to say 1.07 to the 15.
Yeah, you divide 3,000.
Yeah, I'm going to walk you through it. Times 1,800. So here's what. So I need everyone's attention up here. This is the next thing that happens. Again, you know how much I love you, and I do. I am always surprised because these are real life problems, real life things that are happening. Your calculator, Colton, is willing to do you dirty. It is really like if you miss your finger slides, you hit a negative, it will give you weird answers. These are real life problems. I have made things that really happen. I'm not having you buy 3,000 watermelons. No, this is a real thing that can happen, that you can really invest this kind of money. So if you get an answer like 0.63, that doesn't make any sense. If you also get a number like 500 million, that doesn't make any sense. So before you write answers down, make sure they kind of make sense. Guess what? I'm going to get about $4,900. Yay for me, right? So yeah, you make a good amount of money. You did nothing, and that's your Nana money. Your Nana money's looking pretty good. Are we good? Everybody okay? Okay, let's go to the next one. It's going to get a little weirder. And yes, don't judge me. I have no friends. Okay, so here's what happens. We got Nana, and we're going to put someone. Now, did I just pick people who had black shirts on? Yes, I did. So I've already had Taddy do it, and I've already had Brady do it. And isn't this little Adam?
Oh, Adam, you look so good.
I know that. Oh, that's so mean the way you said that. Like he doesn't normally. Look! Oh my God! That like you could take that picture. It looks like it really. Someone else like, did you really get the whole body? I'm like, no, I did not. But that's fire. That is fire, right? So there we go. And that's really probably what his Nana looks like. I don't know. So here we go. Let's do this problem. But let's cross off that we don't want Owen. That was from last year. Let's do Adam, his Nana, his Meemaw. Meemaw's helping him out. And she told Adam that he can't take it out. And how long till Adam can spend that sweet, sweet Nana cheddar. Okay, here's what we want to do. Let's start with this. APRT. So here we go. Nana gives Adam $2,000. APRT, what is that? P, that's where we're starting. $2,000. Adam wants that money. He wants it now. And Nana's like, not till it gets to 3,600. So he's like, fine, I'll wait. 3,600. She doesn't have quite as good an interest rate. And you're going to see that makes a big difference. So this time, her only 0.6% or 0.6%. How long till he can take it out? Let's set it up. So we're going to say 3,600 equals 2,000, 1.06 to the T. Okay. Our job is to get, just like the problems in the beginning, we want that alone. So the first thing you need to do, get rid of the 2,000. Divide those sides by 2,000 before you start.
Can you see one of the story says
1.8 equals 1.06 to the T. Okay, is everybody with me? Now I'm going to use my tool of ln to bring the T down, right? So here we go. I'm going to ln this side, ln this side. Let me get rid of Adam's name right there. And I am going to drop this T down here.
Wait. Who follows this?
Okay, so then I start separating, right? Because I am taping. Put your phone away. I don't want to have to start collecting because that'll be the next thing. So here we go. ln, especially when I didn't feel like our quizzes were a little bumpy for me. Are we ready? Okay. Now, before you write an answer down, make sure it makes sense, right? He's going to keep it for a while, right? But he's not going to clearly keep it for 300 years. Nana will be dead, right? And he's also not going to keep it for 1 year because he's not going to make that much money in a year. So if I get something like, around, I would say 5 to 15, that should make sense. So go ahead and do your math here, right? So ln 1.8 divided by ln 1.06. I'm going to say so you're going to write the answer in years, round to the nearest year, right? He's going to leave it in about 10 years. And you want to write the word year, don't just write 10.
See, don't you have to round up?
In this case, I got 10.08. So
I know, but you it's saying it's 1.01, and that's the first one. So
1.01 is still 10 years.
January. But it takes 11 years to do that.
Oh, I see what you're saying. Actually, you can pull it out mid-year. You can pull your money out.
All right, bro, stop looking at me. I can't. How'd you get that number?
Are we good?
Exactly what you did.
Are we good?
How did I get 1.3?
Everybody good? Okay.
1.8, not 1.08. What's up, bro?
Next one. Here's what's happening. We are depreciating. We are decaying. Things are falling apart because they do, right? You buy a new car today, it is not going to be worth what you think it is even in a year from now, right? In 5 years, your car is not worth nearly as much. It's got a rate of depreciation. What changes? Here's what changes. Are you ready? Same formula, but this time we're subtracting the rate, right? Everything else works the same, but you're going to be careful on this one. You're going to get a lot of 0.98s and 0.93s, right? Because your rate of depreciation is usually going to be like 4%. So it's 1 minus 4% or 1 minus 0.04, which is 0.96. So we're going to be a little careful on these, right? So when I did this one last year, let's see, who do I want to, I'm going to do this. Danny has decided to start a business selling turtles because sure, that's what Danny's going to do. And he goes, Miss T, I need you to front me some money for my turtle sale business. And I'm like, well, how much do you need? He goes, 12,000. I'm like, okay. And he goes, I promise you're going to make money off this investment. Well, it turns out no one buys turtles. It's a weird thing to sell. So what I want to do on this one is I want to talk about the fact that poor Danny has been losing money. Every year he tells me it's going to turn around this year. And every year it doesn't. So Danny, I've invested 12. He is losing money at a rate of 4%. I've invested for 9 years. How much money is left? Now be careful. Everyone always thinks that the A is the big number and the P is the little. Not necessarily true. So here we go on this one. A, P, R, T. We're going to start with 12 grand that I'm investing with my friend Danny, and he has got a 0.04 rate of depreciation or of loss, and I'm gonna stick with him for 9 years, and then after 9 years I'm pulling my money out because that's enough of that. I know. You know what? I believed in him. I did. I believed that the turtles were going to turn around any moment now. What? Careful on this one. Watch what it is. 0.96. Do you see how that's less than 1, right? It's 1 minus. Make sure you know how to work your calculator. That's all we're doing on this one is making sure you're calculating. Yeah? So, and again, make sure the answer makes some kind of sense before you write it down. It looks to me like on my multiplier, 0.69. Oof, that's not great.
Yeah.
So after 9 years, I really thought the turtles were going to take off, but they never did. So I have $8,300 or $8,310. So another question could be, how much did I lose? I might ask, how much money did I lose? And you know what I'm going to do? Take the 12,000, subtract what's left. So I could ask, how much did I lose? Figure out what you got. We got one last one and we're wrapping up. I told you I like these problems. And this, I got Zach and Kathy on this one. This is a true story. I looked this up last night with my daughter. She would like a fancy handbag, and I laughed at her and I said, that will never happen as long as you're a teacher. Wait. So I had to go with people who had gray shirts on. Do I literally go through everything and try to find people with gray shirts? Yes, some of them look really good. Gianna looked really good. But then I tried to use Kathy. So here was my problem with Kathy, is that her shirt's not really gray, it's pink. And so it didn't look right. It was really too clear. So the only person in this class that I could find with a gray shirt, that was my guy Zach. And you know what? We don't judge. We listen, but we don't judge. Because you know what? If he likes a nice bag, he likes a nice bag. And there you go. And you know what? If we move it down a little bit, he doesn't even have boobs. So there we go. So now he's got no boobs, and then he looks perfect. So here we go. Zach likes a nice handbag. Good for him. So here's what I want to know. He buys it for $10,500, but he only wants to keep it long enough so he could sell it. And this is real. You go in the Real or Poshmark, you can sell your bag, but if you use your bag, it's going to depreciate. So go ahead. How long can Zach carry his lovely Gucci bag in college? You know what? I don't know what will look better for him, that it's a very nice status symbol bag or that he's a young man carrying a Gucci bag. So I don't know which looks better. But go ahead, give it a try, set it up.
You spend finding all these pictures.
Way too much time. Well, once I get started, I can't stop. And then it's like, I need one for every class. Yeah. But I did. I had Kathy all ready to go, and I put her on there, and it's like, that didn't look right. And I'm not really sure that that's really Zach's ethnicity. So, yeah, I'm feeling like, and I am going to move him up a little bit because he looks better a little bit higher. Yeah, he's doing the spray tan. Maybe that's, there we go, there. Because that actually looks pretty good. That actually doesn't look right. But there you go. So if you want to take a picture of Zach, get ready to carry his bag. Oh, you know what? I'm going to draw a little purse on here.
Right about that.
So he's got his little Gucci bag on here. And you know what? That's a real price of those stupid purses. Like, that's not me lying. Okay? Yeah, and that's not an expensive luxury bag. I mean,
how much is a Birkin bag?
Like, they can anywhere from 30 to a million. A million. Like if it's a one of a kind ostrich with real gold on it, yeah. It's bullshit. They're super ugly. Oh, I just taped that. Sorry. Okay, here we go. A, P, R, T. Here's what I know. He starts with his bag at 10,500, but it's going to go down to 8,000. Don't let the fact that it's smaller fool you. I have kids who will say the big number always goes at the, oh, that's wrong. That's wrong. I flip that, see? That's what I start with. That's what I end with, right? So I have kids do just what I did. They flip them, right? So the rate, 6% depreciation, 0.6, and we don't know how long. So here's what I've got. He started with a $10,000 bag. I'm going to say 0.94 to the T. Guess what? You're going to start by dividing. Start by dividing. You're going to divide. We want to get, I'm going to show you, we want to get this by itself. So move this over to here. You cool with that? So you can do it on your calculator. 8,000 divided by 10,500. So I get 0.761. And here's what I'm going to do. I'm going to take the log. So I'm going to say ln 0.762 divided by ln 0.94. Okay, I just punched this in a weird way. So I'm going to make certain that my number makes sense, right? So clearly, Zach is not going to carry his bag for 200 years. That's weird. He's clearly going to get to carry it for more than a year, right? So if I get something between like 2 and 15, I'm probably in pretty good shape. And it looks to me like he can carry it for about 4.4 years.
Is that right?
You can, you know what? I'm going to go ahead and say 4.4.
4.3, right?
Yeah. Again, on years, if you want to make it about 4 years, you should start getting ready to sell it. That would make sense, right? Yeah. Because on the year, we can be a little bit flexible, right?
Yeah,
4. It is 4.
Yeah, you did 5. I have 4.
So, 5 would be, here's what's interesting. By 5, it will be under 8,000, right? Good question. Hey, good job, everybody. I like this. I like this. Why am I girl again, boys?
A year. A year.
We're doing